Thank you, Jessie, for the introduction. Dawn mentioned it in her talk. Communities are important. Communities help people getting better, and I really appreciate that NetWays take care that we also have a community around here where we share ideas, where we share knowledge, and maybe even share things that are not working. So my talk is about, people might know me, otherwise just move on to me, ask me. I'm happy to answer questions. People mostly know me because of my long-term Puppet usage, and I still receive the questions, is this still in use somewhere? Yes, it's still in use, and there's a valid reason for that. So today I'm going to take you on a short journey. We're moving a couple of years back into the past, talking about configuration management. Where did it evolve from? How did it came up? How was this related to the DevOps community? We will then move on to workflows, and I want to explain also what are the differences between configuration management, workflows, and orchestration. So in the past, let's say moving back 15, 16 years, people were setting up systems manually. Chris had a talk about this in his slides, the early beginning. What happened? Manual work causes manual action. Manual action is usually error-prone. Everybody knows that. Configuring 300 servers with a new DNS server, maybe you missed one because it was in maintenance, powered off. Afterwards, the system comes up and something is not working properly. So you have outages. You need new setups for new applications. You see, the development moves on. You want to give new things to your customers. So developers develop new things, and you have to ensure as an ops person, how am I able to run this new application in my existing infrastructure? Sometimes you even have unreproducible changes. I saw that a customer where we had to deploy a fix manually. It was an extraordinary, we received the extraordinary allowance to deploy this fix. Unluckily, some people forgot to record that the fix was done. So it was not reproducible because it was never written down that this change is required for a platform. Or you have incomplete changes, maybe. So in the first talk this morning, there was a sentence saying, production is the happiest place in work. I can still tell you a couple of years ago, production was not really the happiest place in work. Sometimes it was, but when there have been outages, things went totally crazy. As I see a couple of other people, maybe a little bit gray-haired, or wearing beards, or, okay, let's stop that. In the past, do you still remember, raise your hands, if you have ever had your own scripts for automation? Having shell scripts, for sure, we had it also. Then we moved on to version control and we learned, wow, we have 3 different sets of scripts for our production servers and all of them are right. So, but we have to combine everything to have the full picture again. Changes could not be done because of hardware maintenance. Yeah, the power supply failed, so there was no server available, not at least over the network, that we would access the system and do a change. And then the system was spin up again. Of course, it was unchanged. And there's even more. Accidentally omitting a server from a deployment. Why? We had manually server lists, and everybody had its own. And the new colleague spun up a new server because they were happy the new hardware has arrived. Yeah, but he hasn't announced that to everybody that the new server is already in production state. A development that must be done in the middle of the night because the development might take 6 hours. Wow, at least one other person. My graduation is that you had to do it this way. The longest deployment in such a manual matter, let's say scripted matter, we started at 8 o'clock in the evening because everybody was looking football. It was a European Champions League or something like that. It was the final. So we knew, of course, nobody will look for cars at this time because everybody is sitting in front of the television watching football. And we had the clearance that we can continue with the deployment up to 4 o'clock in the morning. If the deployment will not be functional by 4 o'clock in the morning, we must revert and restore the database from the backup. So, the most happiest place, the production environment. More than 10 years ago, we had new things coming up. We had something which we called configuration management. There was BCFG2, there was CF Engine. CF Engine with a specific focus on just describe the change. So add a line, it's missing in the configuration file. Puppet moved that into version control and allows the administrators to see the full file and not only the change. So you don't have to grab to 500 changes to find the final state of the configuration file. It also added something which we call declarative state configuration. One of the reasons I'm doing this talk is the limitations of declarative state configuration. A couple of years later, Ansible showed up, and Ansible was the first one that moved from a client-server model, a pull model, to a push model, saying, I'm responsible for the server, I have SSH access. What all these tools have in common is that we say we do something which we call now infrastructure as code. So we work with version control. We test our things that we put into version control. So you can see it's similar like being a piece of software. A piece of software is code. It just not describes an application. It describes an infrastructure. Some people started naming this, at least in the beginning, it was the DevOps movement. Because mainly it meant that ops people started technology which are usually used by developers, version control systems, CI/CD systems, something completely new. Personally, nowadays, I must confess that as a DevOps, I see a developer that develops an application and they care that this application is running properly. And an SRE is the old ops person that builds infrastructure that allows developer to automatically deploy their applications. Just a little other understanding on DevOps and SRE. Declarative state being a problem. Why? Within declarative state, I tell how the system should look like in its final state. I'm not saying run this script, run this script, run this script. I'm saying there's the package, there's a configuration file. Maybe there are 15 configuration files, and they all together build up a specific service. And out of these, I have plenty on my servers. But how do I deal now with things that are hard to do in declarative state configuration? I have to stop the application, do something, and restart the application. The final state is the application is running. But there are steps in between. Developers want a new anonymized database dump from the production server. This is manual steps, or at least it has been done manual steps, but I wanted also to do this in an automated pattern and not doing it manually. But I can't do this with declarative state configuration. And this brings us to workflow management. People might now ask, what is a workflow? From my understanding, a workflow is anything that is not describable in its final state as declarative state configuration. It is usually done via a script, commands that are executed on a server. And these are things that I consider being a workflow. Once more, the declarative state configuration describes the final way how the system should look like. And any system that does declarative state configuration follows these principles, comparing the existing state, verifying it with a desired state, and if there is a configuration drift, you eliminate the drift by adopting the desired state to the system. But it does not allow, especially in the Puppet world, to do conflicting changes. So saying, I first want the service to be stopped, then I'm doing something, then I'm starting the service again, then you will usually receive an error that you have described the state of that application twice. Well, what is the right one? Should the service be stopped or should it be running? It's a little bit of a problem. It hasn't been a problem for users who work with a push deployment because they just have SSH access and they just say, run the following commands in the following order on the following amount of systems. Basically possible because we're not pulling something, but we have the possibility to just, let's say, abuse Ansible for remote command execution. But Puppet is different. Puppet runs in pull mode, verifies the state. And there, Puppet has developed Puppet Bolt. And within Puppet Bolt, we can add tasks to it. Tasks usually are scripts, which can be Python scripts, Ruby scripts, shell scripts, PowerShell scripts, and you have a describing file, a JSON file next to it, which provides you with information about parameters that you pass on to the script. Why do I need this configuration file about parameters? Do you do in scripts data validation? You have a parameter where you say, I'm expecting a bool value. And now someone gives you a parameter and quotes the false value, which makes it a string. And when you do the Boolean evaluation, you will receive true because it's a string with some content. Therefore, you want to have a file that describes which parameters are available so you can ensure that the users will provide you with the right data types. Am I expecting a string? Does it may be empty? Is it an IP address? Is it a bool value? And afterwards, now you will see that I am not a developer. The only thing I can do is writing ugly shell scripts, is that you have the shell script itself, and you just say, this is the shell script that I want to run. Super simplified, stop the application, do something, start the application. And maybe even put an exit 0 at the end of the line, so everything is always working. Both implementations from Ansible and from Puppet rely on SSH connections. So you need, or WinRM connections, you need access to the final system. Maybe you need a jump host in between when it's a specific network zone. For the Puppet users, they can make use of Puppet Bolt. The Ansible users, they have this built into Ansible because they have the push model. The nice thing is now within Puppet, then you can place the tasks inside a module. And this is also used in the open source community by saying we have specific, let's say, extensions or libraries that extend the functionality of Puppet, and also some of these might have tasks so that you can, for example, in the apt module, run an apt-get update or an apt-get upgrade. You can deliver them, and other people can participate on the work or even contribute and enhance. And now we have security jumping in, telling you, oh, SSH access to that specific network zone. Where do you want to like to access these systems from? From your workstation? Oh, no, you have to authenticate via a token over here. You have to authenticate via some kind of third person agreeing that you access that system, and then you can jump onto the final server. I know many organizations that say SSH is something super bad. They don't like that. If you ask security, how about shutting down SSH? We had that at a customer. They were celebrating. It's like, that's awesome. Nobody can access the systems doing manual changes anymore. And this is also possible with all implementations, that you can access the systems, run tasks, run on-demand things on a platform without the need of SSH access. You just need something in between which ensures that somehow this information is transferred to the final destination server. Ansible users either can use Tower as the enterprise solution or AWX. Puppet users can make use, paying money, Puppet Enterprise, or they can use Coraya as the open source solution. What is similar to both solutions, or all four solutions, is that they are not using SSH anymore, but they're using a message queue. Which means, on the other hand, on the final system, you need somehow a little client that connects to that message queue, checking, is this message for me? Should I do something? So what could be a workflow? As I already mentioned, we had that a couple of times at the company I was working for. We need an anonymized database dump from the production server and a fresh dump, and we need it in the development environment. During an application update, we must refresh the application caches while the application is stopped. A weird principle, but seems to be technically possible. And yeah, we had one customer where we had to do this way. Or even one other solution, I want to get feedback on my application configuration for people that don't have access to the platform, but who will check that the application is configured in the right state. So we had a customer asking, we have these hundreds of JBoss servers over there. Can we please get also a sanitized dump with credentials removed from all of these configuration servers? And please, We are Windows users, we have Excel. Can you please provide this information as a comma-separated value file? A nice example for a task that you run on plenty systems. On plenty systems. But now we have something like that system relies that another system is available. Right? You must spin up systems in order for your application to be fully functional. How can we ensure that if we build a new platform, that everything is done in right order? First, we need all of the VMs. The VMs must be available. The VMs must be integrated into infrastructure, and then we can continue with the application deployment. And this, within that ecosystem, is something that I call the orchestration management. Don't get confused with Kubernetes being an orchestrator. We're talking about legacy infrastructure here at the moment. So what is it, orchestration? That's actions that must be done in a specific order over a certain amount of servers. Not only one thing that you do on plenty or a single server, but you must do an action on maybe a couple of servers, but in a specific order. Like I already mentioned, spinning up new VMs, integrating in the infrastructure, and afterwards run the application deployment. Or even more worse, and don't laugh, I've seen an application like this. How do we deploy this application initially? You must first start the security service. Then you can start other services. Then you must reconfigure the security service into a locked state, and then you can restart the security service so that no additional services can connect and receive tokens or tickets or certificates or something like that. So it was even a loop inside the application. How do we deploy this application? Again, we are asking ourselves, how can we make use of that? The first one is Ansible users will tell me, we have host groups. We have host groups, and we tell, first run on that host group, then on the next one, then on the next one. And Puppet users will tell you, we can make use of Puppet plans. Puppet plans are no longer shell scripts. You can write plans either in YAML with some kind of limitations, or you can write them in the Puppet domain-specific language, so in the Puppet programming language. And these are usually executed on some kind of orchestration host. Whether this is the host that connects an entry or adds an entry to the ActiveMQ, for example, or to Tower or to Puppet Enterprise, or whether this is a system where you jump onto all the servers connecting via SSH, that's up to you and your infrastructure. Within a plan, I can then describe to Puppet which tasks, which commands, which scripts should be executed on which servers. Again, a short example, and we can see this is again located inside a module. So if you have your application module available, you can write inside that module, add your plan for how to deploy and update that application. Again, we have parameters, and again, we have data validation for our parameters. Chris mentioned it. We have something which we could consider being an asset database, CMDB. Within the Puppet ecosystem, we usually have the Puppet server and the Puppet client. And the Puppet server collects all information from all servers in the data center. So it even allows us to not specifying directly use that specific server over there. Oh, wait, we have a new one. It's again like manual host list. Instead, you can query the asset database, the PuppetDB, for information about certain information for systems and collect these information from PuppetDB. For example, you can say, I have information added inside the certificate that Puppet used to authenticate, the primary server used to authenticate Puppet agents. So in this case, you can, for example, query what is the stage that the system is running in, and what is running on the system, and maybe if it's a larger application, what kind of service of this application is running on. And you can then query from your orchestrator into the PuppetDB service and get a list of the servers from your inventory database. Did I mention that I don't like to have you longer here because everybody is waiting for the social event? So that's the reason why I'm already coming to my summary. In general, configuration management helps us, organizations, individuals, to build platforms that we can easily scale because we have the infrastructure, there's code written down. We just need to check, do I need to add some more information for that new server, or do I need to add this information on the new servers to some others? But the spin-up time is reduced heavily, which allows also spinning up new applications in a faster way because you can adopt most of the stuff like integrating in your infrastructure. So it's the time to market that is very important for managers that say, when can we make money with that application? We're waiting now since 4 weeks. No longer 6 months, we already do agile development, so that's the nice thing. Again, it's the second thing, hardware failure. How long does it take to spin up a new system? The mean time to recover. And how much work is needed? How many people do I need to recover the system? I've seen that once when the primary database server went down. Oh my God, what a nightmare. Everybody was checking wiki pages. They found 3 different ones on how to restore the primary server. Now you have it inside your code base, everybody collaborating. So configuration management is something that helps you to reduce time and effort, that gives the people more time to either maybe contribute to open source products, open source projects, or check out what is the new modern technology that we would like to implement or that we need to implement in our infrastructure. Workflows are needed to automate single tasks. If you need to do something on demand, extending SSL certificates, that's not something that you would like to do on every Puppet run every 30 minutes. Or also a valid option, yes, renew the certificate anytime, yeah, that's okay. But most people don't like to do that. Or if you have to do something that conflicts with a declarative state configuration. Last but least, the orchestration. Orchestration gives you the full picture of your application and your infrastructure. What is needed first? What is needed last? What is it that I must deploy in order so that my application stack is fully functional? Deploying a 3-tier application, patching a cluster, OS patching a cluster. Start with the passive mode, switch over, and then take the second node. That's not something you would like to do manual. Manual work is always error-prone. Scripting it down, checking always the results of the what happened in my last command, and then make a decision, do I continue or do I stop? We can also confess that every actual configuration management solution, Ansible, Puppet, all have these implemented. Ansible has it per se because it's doing an SSH connection, just jump to the system, do something. Puppet, of course, you need tasks and plans to achieve the same. And I did mention that this is mostly mentioned for legacy platforms. And now people say, well, with containers, we don't need this anymore. You're still doing it. You're giving it another name. It maybe has another reason why you do something. But when it comes to containers, you still have something like configuration management. You're not permanently managing something. But somehow in your Docker file, you describe how your application inside your container should look like. Which version is it that you would like to have deployed? Maybe a configuration file next to it. When it comes to workflows, you might have something like Compose or Helm, spinning up systems in a specific order. And when it comes to orchestration, it maybe means that you would like to prune a server because of maintenance on the hardware. So you want to ensure that the applications continues running, but you get freed up that server for your specific hardware maintenance. This is what we then call orchestration. So all of these are still valid, but just used in another way and used in another focus. With that, I no longer would like to block everybody from the social event. Thank you.